Welcome back, dear students. This is Pranav Jyotidas back again to assist you in learning the lesson electricity. In this lesson electricity, today we are discussing the last part of this lesson, and today's topic is heating effect of electric current. So in this lesson we will try to understand how and why heat is generated in a conductor or in a resistor. To understand this, let us first discuss certain examples from our day-to-day life. Have not you used a mobile phone? If you touch a mobile phone which was operated for some time, you will feel that the mobile has become hot. Similarly, a glowing electric bulb, always hot. And at the same time, you can take another example. If you touch the backside of a television which was operated for some time, you will always feel it is hot. The question arises why and how the heat is generated in those electrical appliances like the operated mobile phones or the backside of the television cabinet or even in the glowing electric bulb. How this is heat generated there? To understand this, we have to discuss this lesson, that is heating effect of electric current. When electric current passes through a conductor, then we always know that a conductor has resistance, and due to resistance, electric conductor always opposes the motion of charges through it. As a result, between electric current and resistance, there is a kind of phenomenon, and as a result of that phenomenon, in the conductor or in the resistor, heat is generated. This phenomenon of generation of heat in a conductor or in a resistor is called as heating effect of electric current. So let us come back to this definition. When electric current flows through a resistor or through a conductor, then there is always heat generation in the conductor or heat generation in the resistor. This phenomenon is called as heating effect of electric current. Then that resistor or the conductor where heat is generated, that is called as heating element. That means the element which is heated up due to passing of electric charges through it. Means due to passing of electric current, the element which becomes hot, that is called as heating element. And the heating element should have some properties. What are those properties? Let us discuss them. The first is the heating element must have a moderate resistivity. Means its resistance should be moderately high. If a conductor has very less resistance or very less resistivity, then it will never be able to generate much heat on it. So if you really want to experience heat in the resistor or heat in the conductor, then definitely the resistor or the conductor must have moderately high resistivity. The second point is that it must have high melting point. Since due to passing electric current through the conductor, it becomes hot. The most important phenomenon, the heating element must have that it must have high melting point so that it doesn't melt at that temperature. Third is that it should not burn or oxidize at that temperature, at that high temperature. Because these are conductors or these are resistors and they are made up of metal, and metals have a very important characteristics that they can get oxidized, means they can react with oxygen in high temperature to produce metallic oxide. Now if the heating element get oxidized, then definitely it will be spoiled. That means the conductor will never maintain its property of conducting electric current. Therefore, under that condition, when heat is generated, still if it continues to remain as a conductor, definitely it must have the third property that it should not burn or it should not get oxidized at that high temperature. And the fourth, that is last but not the least, and it is that its thermal expansion should be minimum. We know that when heat is applied, a metal, not only metal, every material actually expands. But if it is a heating element which is generally a metal, then definitely metal also will expand on heating. But if it is to be a good heating element, then its expansion rate should be very less. So these are the 4 important properties a heating element must maintain. Now the question is how that heating effect of electric current can be measured, how it is calculated, how it is derived. So let us come back to this point. When Q amount of charge is carried under a potential difference of V through a conductor or through a circuit, means you are having a conductor or you are having a circuit, and through the conductor or circuit you are allowing Q amount of charge to flow, and for that you are applying a potential difference of V. Under that condition, definitely the electric charges will do some amount of work in the conductor, or it will do some amount of work in the circuit. What is that amount of work? The amount of work is W. That is, at that time the work done is W. Under that condition, we have a formula that we have discussed in our previous classes, and the formula is W is equal to V into Q. Means work done by the charge in the circuit is equal to potential difference V into charge Q. How did we get it? We got it from the formula V is equal to W by Q. Means potential, electric potential is equal to work done divided by charge. So from this we are getting the relation W is equal to VQ. Now W is equal to VQ means W is equal to V into IT. Why? Because Q is equal to IT. And we are getting this from the equation I is equal to Q by T. Means current is equal to charge divided by time. That is I is equal to Q by T. Therefore Q is equal to I into T. And in place of Q we are putting the value I into T. So W is equal to V into I into T. In the third step we are doing W is equal to, in place of V we are putting another value, that is I into R. We are getting it from Ohm's law. From the Ohm's law we know that V is equal to IR. Means electric potential is equal to current into resistance of the conductor. So V is equal to IR and the remaining part is same into IT. So if we simplify it, it will be W is equal to I square into RT. So this is the formula by which we can measure the amount of work done by the charge in the conductor or in the electrical circuit. In this case, the work done by the electric charge will appear as heat energy in the conductor. So work done by the charge will be always appearing in the conductor in the form of heat. So that heat is represented by capital H, and under that condition we can write W is equal to I square RT, means heat is equal to I square RT. So mathematically H is equal to I square into RT. And this heat will be calculated in the unit called as Joule. So Joule is the SI unit of heat energy. Now sometimes heat generated in this circuit or in the conductor will be measured not in the terms of Joule, but it may be calculated or it may be expressed in the form of calorie also. Now if it is calorie, how can we get the relation between Joule and calorie? For your in simplification I am giving it, 1 calorie is always equal to 4.18 Joule, or approximately we can say 1 calorie is equal to 4.2 Joule. So this is how we have found that heating effect of electric current can be measured in a conductor or can be measured in an electric circuit. Now let us come back. We have already come to know that H is equal to I square into RT. This is the formula. So if this is, it will show another very interesting thing. What is that? We will get 3 important observations from this formula. H equal to I square into RT. From that formula we are going to get 3 important observations. Observation number 1, that is observation A. What is that? If R and T are kept constant, R means the resistance of the conductor, and T is the temperature. If we can keep, sorry, not T is the temperature, it is the time period. So if we can keep the resistance of the wire constant, R constant, and T constant, means time, how long you are applying current, that time I am talking about. If you can keep the time also constant, that means in this relation you are keeping R and T constant, then H is equal to I square. Since R and T are constant, you will get a relation like that, H is proportionate to I square. What does it mean? It means that heat produced is proportional to the square of the current. Means if you are increasing the current 2 times, then heat generated will be increasing by 4 times as a square. If you can increase the current 3 times, then heat generated will be increased by 9 times in the form of square. Similarly, if you reduce the, here that is resistance, if you reduce the current to half, then heat generated will be reduced to 1 by 4 times. So this is how we are getting from this relation H is equal to I square RT. Since R and T you are keeping constant, the first observation you are getting that H is directly proportionate to I square. Now the second observation from the same formula. What we are doing this side, we are keeping current and current and time constant. If we can keep the current and time constant, that is I square and T will remain constant, then you will get H will be proportionate to R. That is H is proportionate to R. Means heat is directly proportional to the resistance. It means that if you increase the resistance of the conductor, then heat generated also will be increasing. If you increase the resistance by 2 times, heat generated also will increase by 2 times. Similarly, if you increase the resistance 3, 4 times, 5 times, heat generated also will increase 3 times, 4 times and 5 times respectively. So this is the second observation we have got from this relation. And the final observation is that if we keep current and resistance constant in this one, current that is I square and resistance, these two if we keep constant, then the relation will be H is proportionate to T. It means the heat generated is directly proportionate to the time of flow of electric charges through the conductor. That means if we increase the time of flowing of charges through the conductor, then heat generated also will increase. If we increase the time by 2 times by keeping current and resistance constant, then heat generated also will increase 2 times. Similarly, if we increase the time by 3 times, heat generated also will increase by 3 times. So these are the 3 observations A, B and C we are getting from this equation H is equal to I square into RT. Now the question is, what are the different applications where we can apply these principles of science, heating effect of electric current? Why it is important? Why should we study? The answer is, really it is very important because we are using this phenomenon in making many electrical appliances. And the first of them is, number 1, the electric heating appliances like an electric iron. That is maybe electric water heater or geysers that we use in the bathrooms, or the toasters or heating coil, room heaters, etc. All this work on this principle because we are using some coil made up of certain metals which have high resistance, and for that reason, due to more resistivity of the material, those materials get heated up when electric current passes through them, and for that reason an electric iron becomes very hot when we apply electric current in it. Or a geyser can make the water hot inside in its container when the electric current is on. It is because of the heating effect of electric current. Second application, the electric fuse wire, which is actually made from low melting alloy. It gets heated up when large amount of current passes through a circuit. In domestic electric circuit, we always use a fuse wire. That fuse wire is made up of a special alloy which have very low melting point. Means at very low temperature even it will melt down. When suddenly high voltage is there, a large amount of current will enter into our home and it may damage the entire wiring, or it may damage the different electrical appliances inside our home. How to prevent it? To prevent it, before the electric current enters our home, we use an electric fuse wire. Since through the fuse wire, high amount of current will pass, the fuse wire will become hot, because this is because of heating effect of electric current. As a result of increasing temperature in the fuse wire, as we have mentioned, it has a low melting point, it will melt down, and as a result of that the circuit will break. As a result, the current will cut, and means your home will not get electric current, your appliances will not get electric current, and in that way we can prevent short circuit in our home. So this is another very important applications for safety purpose we use in our domestic wirings. Third one is that the electric filament bulbs, they contain a high resistant tungsten wire which gets heated when current passes through it, and it becomes red hot and then it starts glowing. The electric bulbs, the ordinary electric bulbs, they have a filament, and that filament is made up of tungsten. Tungsten has very high resistance. As a result of that, when current passes through the tungsten inside the bulb, it becomes very hot, and it becomes so hot that it starts glowing, and from that glowing tungsten filament we start getting light, and this is how an ordinary electric bulb starts giving or emitting light. So these are certain examples of applications of heating effect of electric current. So this was what we wanted to discuss in this lesson, and that is the end of the chapter electricity. In our next class we will start a new lesson. Thank you very much.